So for this video, we're going to discuss the next topic under matrix algebra, which is transpose, conjugate, and tranjugate of a matrix. So another operation that we apply on matrices is what we call transpose. So the transpose of a matrix is denoted by the superscript T. So for some references, instead of E raised to T, they use A apostrophe. So for our discussions and for this subject, what we're going to use is A raised to T. So what is now the transpose of a matrix? So any matrix having a size Mn will have a transpose that will have the size Nm. So what does this mean? It means that if I'm going to get the transpose of a matrix, the column now of that matrix will become the row of the transpose, and the row of that matrix is equal to the column of the transpose. So to understand this statement, let's have this matrix. So if I will have matrix A with elements AB for the first column or for the first row, and CD are the elements for the second row, if I'm going to get now the transpose of this matrix, okay, so the column now, or the first column of our given matrix, will become the first row of the transpose. And the second column of our given matrix will be the second row of your transpose. Okay? So in transpose, it's just like you're making the column or changing the column into a row if you're going to get your transpose. So transpose will simply mean you change it from column to row. So another operation that we apply on matrices is what we call the conjugate. So denoted by the name of the matrix with a bar above it. Okay? So the conjugate of a matrix is the matrix whose elements are the conjugate of the elements of A. So what does this mean? So the conjugate basically will only be applied to matrices having complex numbers. Okay, so this is obtained by taking the complex conjugate of each element in that matrix by simply changing the sign of the complex value. So to understand that, let's have matrix A with elements I3 for the first row, and we have -2 and -2i for the second row. So if I'm going to get the conjugate of matrix A, so I is a complex number, so I will just simply change its sign convention. So it will now become -i. And then the second element is not a complex number, so there is no change that will happen on it. And then for the first element on the second row, we have A21, which is -2. Again, is not a complex number, therefore no change is applied. And lastly, we have -2i, which is a complex number, thus the result now will be equivalent to +2i. Okay, so again, the conjugate is simply taking the negative value of the complex element, or the element having a complex value. So another example, let's have matrix B with the following elements. So what we are going to change here are those elements having a complex number. So the conjugate of matrix B will now be equal to 1 minus 2i. So ang papakialaman lang will be the complex number. Okay? Next, we have -3i 2 for the next complex number. That will now be negative 3 plus 4i. And then we'll have negative 2i and negative 4. Okay? So conjugate is only applied on the complex number. So if we have a combination of a real and complex number, then we will not do any change on the real number. We'll only apply our change in sign for your imaginary or complex values. Another operation we apply on matrices is what we call the Tranjugate, which is denoted by the name of the matrix and an asterisk beside it. So the Tranjugate is also referred to as your transpose conjugate or conjugate of a transpose. So this means that you have to take first the transpose of the matrix and then you apply the conjugate. Or it is also equal to the transpose of the conjugate matrix, wherein you take first the conjugate before transposing it. So either way, you will have the same answer. So to understand this further, let's have an example. So given matrix A with the following elements, 2i, 3, and negative I, 1. So we first take our transpose. So the column becomes the row of the transpose. The second column becomes the second row of our transpose matrix. So once we have taken your transpose matrix, we now take its conjugate. So from this matrix, our tranjugate now is equal to negative 2i, positive I, 3, and 1. So this is now the conjugate of the transpose. So another way, you can also, instead of taking the transpose first, you can get the conjugate first, in which we'll have now negative 2i, 3, positive I, and 1. Then once you have taken the conjugate, we can now apply our transposition. So we'll have now the first row becomes our first column, and then our second row becomes our second column. So as you can see, we both have the same answer. So whichever comes first, it will still give us the same value of tranjugate. So for a transpose, it would now follow different properties. So we have the first one, wherein the transpose of the transpose is simply equal to the original matrix. And then, taking the transpose of the product of a constant and a matrix is the same as taking first the transpose of the matrix and then multiplying it to the constant. Also, the transpose of the sum of two matrices is also equal to the sum of the transpose of the individual matrix. Same goes for the product of a transpose, or the transpose of the product of two matrices is equal to the individual transpose of the product of the two matrices, but the order now is in reverse. And then the properties for a conjugate, first one is that the conjugate of the conjugate will result to the original matrix. The sum or the difference, or the conjugate of the sum or the difference of two matrices is equal to the sum or the difference of their individual conjugates. Also, the product or the conjugate of the product of two matrices is equal to the product of the individual matrix, the conjugate of a constant and a matrix is equal to that of the conjugate of that matrix and then multiplying it to the constant. Also, the conjugate of the transpose is equal to the transpose of the conjugate. And the conjugate of the inverse is the same as the inverse of the conjugate. And lastly, the determinant of a conjugate is equal to the conjugate of the determinant. So whichever goes, it will still be the same for conjugates. Then we have the properties that we follow for a tranjugate. So the tranjugate of a matrix, or the tranjugate of the tranjugate of a matrix, is equal to the original matrix. So multiplicative rule, the product of a constant and a matrix, or the tranjugate of a product of a constant and a matrix is equal to taking first the conjugate of the matrix and then multiplying the constant. Then we have the additive rule, the sum of, or the conjugate, the tranjugate of the sum of two matrices is equal to the tranjugate of the individual, or the sums of the individual tranjugates of the matrices. So we also have the tranjugate of the products of the matrices is equal to the product of the tranjugate of the matrix in reverse order. Do take note that the tranjugate, or the conjugate transpose, is used to check special matrices such as the Hermitian matrix, the skew, and unitary matrices. So to understand the three operations that we have just discussed, let's solve some examples. So we have problem number 9. So determine the transpose and the main diagonal elements of the given matrices. So we have matrix A with the following elements. And as we can see, matrix A is a single row matrix. So its transpose will simply be a single column matrix. So our row elements will just simply be our column elements. So we'll have -4, 2, 7, 1, and 8. Let's have another example. Or before that, the diagonal element of our transpose will be -4, which is your A11. Another example, we have matrix B, which is a 3x2 matrix. So therefore, our transpose will be a 2x3 matrix. So our first row will simply be our first column. So we'll have 2 and 3. Our second row becomes our second column, 8, 8. And our third row becomes our third column. So we have 1 and 1. For our main diagonal, that will now consist of A11, which is 2, and A22, which is 8. So if you're going to observe, your main elements will be the same for the original matrix and for our transpose. So another example, number 10. Determine the transpose and the main diagonal of the given elements. So let's have matrix A having the following elements, and matrix A is a 3x3 matrix. in which our transpose matrix will also be a 3 by 3 matrix. So this is the M of T, or the M of our main matrix, N of the main matrix. So this is the row of the transpose, which is also equal to that of the main matrix, to the N of the main matrix. This one is the row of, or the column of the transpose, which is equal to the number of rows of the main matrix. So for our answer, our first row becomes our first column, so we'll have 2, 3, 1. Second row becomes the second column, which is 3, 2, 5. Third column, or third row, becomes our third column, which is 1, 2, 7. For our main diagonal, that will now consist of 2, 2, and 7. So again, observe, main elements of the transpose is the same as the main elements of our main or original matrix. So if you are transposing and the main elements of the original matrix and your transpose are different, there is something wrong with your transposition. So let's have another matrix D, which is a 3 by 4 matrix. So for your transpose, our size will become 4 by 3. So for our given, our first row becomes first column 4, 3, 1, 2. Second column becomes, or is taken from the second row, that is 2, 4, 3, 6. And the third row is our third column. We have 1, 3, 6, and 5. So for your diagonals, that will now be 4, 4, 6. Okay, let's have a practice problem. So find the transpose conjugate and tranjugate of the given matrix. So given G with the following elements. So solve for the transpose, that is now equal to, first, let's start with the first row. So first row, that will now become the column. So that's 2, 5, 3. And then we have your second row becoming our second column, that is now 5, 2, and 4. And our third row becomes our third column, so that is now 2, -2, 3. And then for the conjugate will be the same as our original matrix, as there are no complex numbers. So we'll have 2, 5, 2, 5, 2, -2, 3, 4, 3. So our tranjugate or transpose of the conjugate now is equal to 2, 5, 3, 5, 2, 4, 2, -2, and 3. So if you're going to notice, if there are no, so there are no complex numbers in our matrix, then our conjugate is equal to that of the transpose of the matrix. Okay? And also, if there are no complex number, the conjugate of the matrix is equal to the original matrix. Okay? So for the given matrices, do this as part of your evaluate activity.